Hi everyone, welcome back. What we are doing today is we are looking at grade 10 factorizing. It's an incredibly important section because factorizing comes through in so many different concepts as you go through all the way from grade 10 to 12. So before this break, I was looking at an alternate method to factorize a quadratic trinomial. If you would like to see that method again, please rewatch this if you can. All right, so the last part of question 1 was to factorize this expression which has 6 terms. This can seem very scary because how do you know what to group? There's so many things you could possibly group together. So for example, you might have tried to put 9ax squared with minus b squared x because you can see that there's a common factor of x. What will start happening, guys, if you start with this long expression with 6 terms and you start putting together things, you will quite quickly start realizing that you cannot get a common bracket by putting these pairs of terms together, especially in this question. So in this question, what we have to do is look at maybe grouping 3 terms rather than just 2 terms. So how do we do that? Let's put together the first 3 terms by taking out a common factor of 9a squared. I can see that 9 is a common factor to all the terms. I can see that a squared is a common factor to all the terms. So if I divide through by 9a squared, I'll be left with x. 9a squared y divided by 9a squared will just give me y. Positive 27a squared divided by positive 9a squared would give me plus 3. Now, in the next lot of 3 terms, you can hopefully see that there's a common factor of negative b squared. So let's pull that one out, and you'll be left with x. Minus divided by minus is a plus y. Minus divided by minus is a plus. 3b squared divided by b squared is just 3. Now we can see that our common bracket is x plus y plus 3, and 9a squared minus b squared is what we get left with. This is now an important step because now there's 2 things we need to do. We've got this common factor that's a bracket of x plus y plus 3. We need to pull that out. But at the same time, we see that we are going to be left with a difference of squares. So that means we cannot just end that sum there. We have to carry on further. All right, so what we're going to do, let's go to the next screen and clear this out. So we're going to take x plus y plus 3 out as our common bracket. And we said we'll be left with 9a squared minus b squared. Okay? Now you look at these 2 terms and we see we've got a perfect square minus a perfect square. So therefore I can factorize that second bracket further by saying square root of the first term minus square root of the second term times by square root of the first term plus the square root of the second term. The square root of 9a squared is 3a, square root of 9 is 3, square root of a squared is a, the square root of b squared is simply b. Okay, so make sure that you look at the bracket that you are left with after you've grouped your terms together and taken that out as a common factor. Look at what you're left with and see if you can go any further. If you can go any further, then you must. Okay, let's look at question 2, and this is really where factorizing becomes interesting because often we get asked factorizing as part of a fraction simplification. So it's not good enough to just learn about fractions. We've got to put it together with, not fractions, we mustn't just learn about factorizing, we've got to put it together with fractions. Fractions and factorizing, often those questions go hand in hand. Okay, so let's look at question 2a, and we're asked to simplify. The way we're going to simplify this is by factorizing the denominator. I look at the numerator, there's really not much I can do there, so I leave that exactly as it is. In the denominator, I recognize that I have a difference of 2 cubes. X cubed is a perfect cube, and 8 is a perfect cube because 8 is equal to 2 times 2 times 2. Okay, so the cube root of 8 is 2. So my first bracket, the cube root of x cubed is x. The cube root of negative 8 is negative 2. Your second bracket will be your first term from the first bracket squared and then it's plus the second term in your first bracket squared, so minus 2 squared would give me positive 4. And then your middle term is the product of the two terms, so x times negative 2 is negative 2x, but with the opposite sign. So this will be plus 2x as the middle term in that second bracket. Now that's fantastic, because if I put a bracket around the terms in the numerator, I see it looks exactly the same as the denominator when I factorized x cubed minus 8. So I can cancel out those common factors, and I'm left with 1 over x minus 2. Okay. All right, let's move on to the next one. Once again, in question 2, we are going to use factorizing to help us to simplify this fraction, because what we're going to end up with is brackets of terms that we can hopefully divide through with a common factor. Okay, so my numerator, I've got 6a squared minus 7a minus 3. And you can factorize this either by using trial and error or the method of grouping I've shown you before. In the denominator, we can take out a common factor of b, so we get 3a plus 1. My numerator factorizes to 3a times 2a, and we need to get negative 7 as the middle term, so I'm going to have negative 3 in my second bracket plus 1 in the first bracket. I've gone through that quadratic trinomial factorizing very quickly, but you can use whichever method suits you to confirm that those are your factors, okay? If you multiply out, you will get a middle term of negative 7a, and you'll get a constant term of negative 3 and a first term of 6a squared. We cancel out our common factors, and we'll just be left with 2a minus 3 all over b. All right. Okay, so as you can see, that concept of factorizing, it's important to understand those different types of factorization, because they are often asked in fraction simplification. Okay, those questions with fractions and simplifying can get quite complicated, as we'll see with the next question. All right, so here we are asked to divide these two fractions, and we see that we've got a quadratic trinomial, we've got difference of squares, we've got highest common factors, so many things going on. Our methods don't change, they stay the same. We do what we know how to do. So the first thing I'm going to do is I'm going to rewrite so that you can see this clearly. I'm going to rewrite the second expression by tipsing and timesing. So we invert the fraction, so it becomes times 100y squared minus 1100y all over 4y squared plus 48y. Okay, so I've inverted, or I found rather the reciprocal of that second fraction, and I have change the division to multiplication. Now the next step for me is to factorize each denominator and each numerator so that I can hopefully cancel common factors. So I see that in my first numerator, I can factorize using a quadratic trinomial. The factors of 132 are 11 and 12. 11 plus 12 is definitely 23. In the denominator, I've got y squared minus 121. Y squared is a perfect square, 121 is a perfect square. We've got a difference between them, so this is going to be a difference of squares. The square root of 121 is 11. So we have y minus 11 times y plus 11 times. In the numerator, I can take out a common factor of 100y, and I'll be left with y minus 11. And in the denominator, I can take out a common factor of 4y, and I'll be left with y plus 12. And now we can see that we can cancel out our common factors that appear in the numerator and denominators. Y plus 11 cancels with y plus 11, y plus 12 cancels with y plus 12, and y minus 11 cancels with y minus 11. We then divide 100 by 5 times 4, which is 20. 100y divided by 20y will simply give me 5. Okay, what is so important here is to remember that you cannot cancel across terms. So you cannot in this sum go and see, okay, well, here I've got a y squared, I can cancel that with that. No, we cannot do that. You have to first factorize by taking out your common factor in the case of the second fraction, and then only can you cancel brackets of terms. You most importantly, must remember you cannot cancel across terms, so you cannot cancel across plus and minus signs. All right, guys, we've learned so much today. I certainly hope you have learned so much today. So we're going to end our session there. Hopefully, you understand where you can apply all of the different factorizing methods you have learned. Until next time, keep practicing.